Okay, so today's lesson is going to be on expanding quadratic expressions. So we're really going to use that distributive property that we explored in grade 9 for expanding monomials and binomials and polynomials. And so today we're going to focus on binomials and how we can use that property to help us. So as I just mentioned, last year you looked at the distributive property. So in this example, we have a number outside a bracket. So you learned that that 3 needs to be multiplied by the x and by the 1. And when we execute that, we get 3x plus 3, because 3 multiplied by x is 3x, 3 multiplied by 1 is 3. What if we add a variable on the outside along with that 3? So we have 3x times x, and we have 3x times 1. So if you want, you can actually write in this extra show your work step if you need to, because what we're doing is this here. However, you get to the point where you can do it in your head and you're left with 3x squared, because x multiplied by x gives us x squared. 1 plus 1 is 2, and then 3x times 1 is x. We're not allowed to add the 3x squared and the 3x because they are not like terms. This would be like saying I have a perimeter and an area and I want to put them together, but we can't because they're two different measurements. So what happens when, or not what happens when, why do we need to do this? So if I were to go through and populate this table of values, so if I sub in -6, I'm going to have -6 plus 4 is -2. -6 plus 2 is -4. I'm going to have 8. Okay. Then I'm going to have -5 in there. So -5 plus 4 is -1. -5 plus 2 is -3. So that's going to give me 3. -4 is going to be 0 because we get 0 in that first bracket. Put in -3, we're going to have 1, and we are going to have -1, so we end up with -1. -2 goes in there, we're going to get 0 again. I'm going to put in -1, we get -3 times 1. So we should get 3 here. Put in 0, we get 8. Okay. I think that's it. Okay, now if I do the exact same thing over here, -6 squared plus 6 times -6 times 8, I'm going to get 8. I'm going to get 3. I'm going to get 0, -1, 0, 3, and 8. So you notice they're the exact same thing. So that means we must be able to take factored form, which is right here. So this is factored, and switch it to standard. And some of you are probably wondering, well, what about vertex? Where does this fit in with the whole thing? Well, we're going to be able to manipulate that one as well, but we'll save that for another day. So today we're really going to focus on taking factored form and turning it into standard, which is what we call expanding. So the principle here is that everything in one bracket needs to be multiplied by everything in the first bracket. So here we have y equals, I'm going to have x multiplied by x and x multiplied by 3. So this is like saying I have x times x plus 3. And then I'm going to do the same thing with the 2. So I have plus 2 times x plus 3. So when we expand, so I turn it into something I know how to work with. I have x multiplied by x to give me x squared. And then I have x multiplied by 3 to give me 3x. Then we have plus 2x plus 6. And I forgot an x right here on this 3 because it's x times x, x times 3, 2 times x, 2 times 3. So when I do that, I can combine these middle terms to get 5x plus 6. So that's one way of writing it. Okay. Here, I'm going to do the same thing. I'm going to do these two arrows. So I'm going to do it slightly different. I'm not going to show that in-term step. You're more than welcome to show that in-term step, but I'm not going to. So I'm going to do x times x. I get x squared. Then I'm going to do the same thing with the 2. So that becomes plus 2x. Then I'm going to multiply the negative 3. So I'm going to have negative 3 times x, which is minus 3x. And then I'm going to have negative 3 multiplied by 2, which is going to be minus 6. So then I always, well, I shouldn't say always, I often have like terms. So this becomes y equals x squared minus x minus 6. So this is using the equation when it's given to you. There are a bunch of other ways that you can do this. If this doesn't make sense to you, I'd like you to come see me and then I'll show you some of the alternate ways. If this does make sense, this is the most efficient way of doing it. However, like I said, if you want to see a different way of doing it, please come see me. All right, so here would be some good knowledge questions on the test, and we'll deal with some issues, okay, that we might run into. So right now we're just expanding binomials. They're not necessarily in factored form. So when I expand this expression, we're going to have x multiplied by x, so that's x squared, x multiplied by negative 1, so that's minus x, 4 multiplied by x, that's positive 4x, and then 4 multiplied by this minus 1 right here is going to be negative 4. So then we combine our like terms. So the x squared stays as is. Negative 1 plus 4 is plus 3x minus 4. So in this example, this is factored form, where we would have zeros at negative 4 and positive 1. We just turn it into the standard form, which is useful because then we'll know the y-intercept. All right, so let's do this second example. So I'm going to do the same thing, except now my numbers are a little bit bigger. Doesn't matter. So I have 2x times 5x. So the 2 and the 5 will multiply. We get 10. X and x is x squared. Now for these here, we're always ending up with a quadratic, with a parabola. So it has a degree of 2. So if you don't get an x squared and you notice you have 2 x's, then I would go back and check your work. Then we have 2x times 7. So I have plus 14x. Then I have negative 3 times 5, so it's minus 15x, and then negative 3 times 7, it's negative 21. Now I often have students miss, does it matter the order that I do it in? The answer is no, the order doesn't matter as long as you make sure each term is multiplied by the other term. So now I'm going to clean this up. I have 10x squared, there's no other x squared, so it'll stay like that. Then we have 14x, subtract 15x, so I have minus x, and I have minus 21. So that's simplified as much as I can. All right, so now we're going to change things up a little bit. Now I notice there's a number in front of this bracket. So then I always get, well, miss, what bracket does that 5 go into? Does it go into the first bracket? Does it go into the second bracket? Does it go into both brackets? So if we think about it, our order of operations tell us we do multiplication first, as reading left to right. So I have to take care of this 5 first. So the 5 is only going to impact the first bracket. So this becomes 10x plus 5. And then that second bracket doesn't change. So now I have it so I can do my binomial expansion. So I'm going to have 10x times x. So 10x squared. 10x times minus 3 is minus 30x. 5 times x is going to be plus 5x, and then 5 multiplied by negative 3 is going to be negative 15. So this becomes 10x squared minus 25x minus 15. Now, oftentimes, a lot of books and different things like that talk about this acronym called FOIL, which stands for first, outside, inside, last. Yes, it works, but it only works for binomials, so I don't like using that acronym. I'd rather just think of it as a distributive property being used 4 times, because that's what's happening mathematically. So if you have a tutor or your parents are helping you and they're using FOIL, it means the same thing that we're doing right now, but like I said, it doesn't work for anything beyond binomial times a binomial, and I don't want it to end up confusing you. So the last piece of our puzzle is this x plus 5 all squared. The 2 does not square the 5 and the x on its own. Anytime we're squaring something, it means we are multiplying by itself. So rewrite it so that it represents what's being said. X plus 5 all squared is x plus 5 times x plus 5. So now, same thing. I'm going to do my distributive. So x times x is x squared. X times 5 is 5x. I'm going to do those middle pieces. So 5x, and then we have 5. Oops, I forgot my plus sign. Very important. So then I have x squared plus 10x plus 5. If you had written here equals x squared plus 25, you've broken math. You're missing a term. That 10x isn't there. So this is wrong. Don't do that. Write it out as x plus 5 times x plus 5. So that's just a mechanics. Now let's look at an application. Excuse me. So a parabola has zeros at x equals -1 and at x equals -5. And it passes through the point -3, -4. So determine the equation of the parabola in factored form and standard form. So we're going to start with factored form. So we have y equals a. This is going to become x minus 1. That actually looks like a 4, so I'm going to erase that and fix that. So x minus 1, x plus 5. So then to get the a, we're going to sub in that point that we have. So I have -4 equals a, -3 minus 1, -3 plus 5. So -4 equals a, -4 times +2. So we have -4 equals a times -8. Divide by -8, divide by -8. So we get 1/2 is equal to a. So that means the factored form is going to be y equals 1/2 x minus 1 times x plus 5. So to get standard form, I need to use a distributive property. So y equals, that half, I'm going to put it into the first bracket. So that becomes 1/2 x, because half multiplied by x is just 1/2, minus 1/2. And that x plus 5 is going to stay the same. And you're probably like, oh, fractions. How? We got to use them. So we're going to work the same way. So 1/2 x times x is going to be 1/2 x squared. 1/2 x times 5 is going to be plus 5/2x. Here we have minus 1/2 x, and then the last term is going to be -1/2 times 5, so it'll be minus 5/2, and there's no x. So that simplifies to give us 1/2 x squared. So plus 5x/2 minus, so that's going to give us plus 4/2x minus 5/2. So we get y equals 1/2 x squared plus 2x minus 5/2, because 4 divided by 2 is 2. So that's standard form. If you have factored form, you can get standard form. In the next unit, we're going to learn how to go from standard form to factored form. But for now, we're only going from factored to standard, not in the other direction. All right, I believe this is our last example. Yes, so find the equation of a parabola in standard form that has a vertex of -3, -1, and passes through 0, 8. So this question is kind of, it doesn't necessarily fit so much in here because we've been using factored form. However, you can go from vertex to factored. So I'm going to start with writing the vertex form. So I'm going to have a times x plus 3 all squared minus 1. So again, I got to find what that a value is. So y is 8. 3 squared minus 1. So I'm going to add 1 to both sides to get rid of that 1 over there. So 9 is equal to a. 3 squared is 9. So a is going to equal 1. So my equation in vertex form is going to be y equals x plus 3 squared minus 1. So I found the equation in vertex form, but that's not the form it wants. It wants standard form. So that means I'm going to have to expand. So when I rewrite this, this is x plus 3 times x plus 3 minus 1. So that 1 is just there on the end, and I'm not going to work with it quite yet. So we're going to use distributive property. X times x is x squared. X times 3 is plus 3x, plus 3 in the middle to give me 3x, and then plus 9, and then I have minus 1. So then I have some like terms. So x squared plus 6x, and then I have positive 9 take away 1 is negative 8. So now I have the standard form of my parabola. So in this unit, we can always get standard form as long as we have factored or vertex. And we'll spend another lesson on that where we just practice. I throw a bunch of questions at you and you come up with this specified form. So again, hopefully this makes sense. If not, come see me.